So combined gas law, I go PV over NT equals PV over NT. And the rule for this is that they all must be absolute. Okay, and they have to be the same units. But unlike the ideal gas law, they don't have to be pascals, cubic meters, but they do need to be absolute units. So that means that our temperature has to be kelvins. The N, whatever we use, we could use mass, right? Because mass is proportional to N, but it has to be how much you have, not how much somebody takes away or something like that. Pressure has to be absolute pressure, not gauge pressure, and I can't really think of a way to give you non-absolute volume, but if I can think of a way, I'll throw it at you, okay? All right, so this one only mentions pressure and temperature. So we assume that the volume remains constant. It does say that, right? And it doesn't leak, so N stays constant. If they're constant, they're the same on both sides, so we can divide them out, right? And so now we just have P over T is P over T, right? So P1 over T1 is P2 over T2. Almost said a bad word there. Okay, so pressure 1 is 603 bougelas, which is an absolute pressure scale. Okay, and then our temperature is 312 kelvins, right? And then that is pressure 2 is what we're trying to find, and then 77 kelvins. This looks a lot like the formative assessment. Maybe I took it right from there. Okay, so 603 divided by 312 times 77 is 148.8 bougelas, okay? Now, here's my challenge to you, okay? We can do all of this stuff and set it up in the equation, and this is all fine. But my challenge to you, okay, is that the way these problems work, and this is officially called the Pink Challenge, okay? Don't use the formula. It's like when Obi-Wan Kenobi tells Luke to turn off his computer rangefinder, right? The pressure is going to change. So you have one parameter that's given to you, and they're giving you the initial one or the final one, and they're asking you for the other, right? So the change parameter you just stick out in front, right? The thing that's going to change, right? And then they give you two things. Like I might give you a couple volumes, I might give you a couple pressures, or I'm sorry, a couple temperatures, a couple volumes, right? Maybe a couple moles or something like that. And you decide, using a ratio of those things, what's going to happen here. Now, notice that we're lowering the temperature, and so I'm guessing the pressure will get less. So I'm going to go 603 times 77 divided by 312, right? So take those things, take those ratios, and decide which way they go. So in this case, I decided to go put 77 on top and 312 on the bottom, because I know that the pressure's got to get less, right? So let's just try this. 603 times 77 divided by 312, and sure enough, we get the right answer, okay? And the nice thing about this is it uses, you could get it wrong, but it's just a challenge. Can you do it? For pressure, I think it's dead simple to figure out pressure. I think temperature and volume and stuff like that are a little bit more tricky.